All right, so you got 3.2. Again, I'm sorry I don't have my tie on. It's in my car. I had to go pick up my little boy at school, and then I took my tie off, and then when I came back, I was like, where is it? It's in my car. Nevertheless, Sparky's behind me, and that almost trumps the tie itself, okay? All right, so here's what I got. I got 3.2. I'm going to put the worksheet underneath so you can see it. And I lost it. Hold on. Oh, it's upside down. Not anymore. All right, here we go. Got some vocabulary here. Linear equations in two variables. Now, here's what you got to notice, okay? The word linear has a special word in it. Some people say it's ear, but it's not. It's line, okay? So linear means line, okay? Line. We're going to look at lines today, and that's pretty much it. And what we're going to say is that a linear equation in two variables can be written in the form y equals mx plus b. Okay? Easy. Okay? A linear function is a function whose graph is a non-vertical line. Okay? It's a function, which we talked about, okay, whose graph is a non-vertical line. So you're like, what is a vertical line? Well, a vertical line is one that just goes straight up and down on my graph. So that is a vertical line. So what is a non-vertical line? Well, it's one that has to tilt one way or another, okay? But it just can't stand straight up. It can lie flats, but it can't lie straight up, okay? I love these ones here, okay? They'll say, is a linear or a nonlinear function? So do you have a line? Is it linear? It doesn't look like a line, it looks like a U. So this is a big no. Okay. Does this look like a line? Yep. Line. Here. Does this look like a line? It does. Okay. Does this look like a line? Looks like two lines. Okay, so no. Not linear. Okay, and the reason why is because they are lines, but you need a single line, and only that. All right. I hope you thought that was pretty easy. I don't know if it gets any easier than that. When looking at the data in the table of values, we must determine whether the function has a constant rate of change. Constant rate of change is another name for slope. Okay, and here's what we're going to do. You'll notice that all these here jump by the same amount. 1 jumps by 1, jumps by 1. Easy, okay? Now what happens in the second group? Well, we go from 3 to 5, so we're adding 2. We're adding 5. What are we adding 5 to get to 7? Well, add 2. And then when I have 7, I add 9 to it, I'm going to add 2. So here's the deal. If all of these are the same, okay, then you say it's linear. Okay, so see what we're jumping by every time, okay? So here, again, I'm adding by 1, adding by 1, adding 1, okay? And what's going on here? Well, it looks like I'm subtracting 8. 16 minus 8, you got to subtract 8. Here, to get to 8 to 4, what are we doing? Well, if I want to get to 8 and jump down to 4, I got to subtract 4. And what are we doing from 4 to get to 2? I'm subtracting 2. Okay. And so what does that mean? Well, these are all different. Okay, so these are not linear. Okay. Easy. All right. These two here, we will do live in class. So if you saw us in class on the day that we did this, then you would have known that, hey, we have these answers already. Okay. All right. So which one of these are linear functions? Okay. Here's what you need. You need a single x okay, and a single y. Okay, and they must both be in the numerator. Okay, so let me look at this first one here. Okay, it's actually the second. That has an x, but it has a crazy square root bar in here. Okay, it's crazy. That's bad. Okay, I don't want that funky looking bar there. And so I do have an x, I do have a y, but I do add this strange operation with that x. Okay, so that means no. Okay, it's not linear. Okay. Again, I do have an x, I do have a y, but your x is a power. Okay, x is a power. That's also bad. Okay, so that's also a no. Okay. Here, x is in your denominator. That's also a no. You can't have x's in your denominator. Okay, they must only be in the top part or the numerator. Okay, and if you look at this, this is good. Okay, because x is up here in the numerator, and if you distribute it, you get 6x minus 6. Remember, distributing takes the 6 and multiplying it by both those. Okay, and that now matches y equals mx plus b, which is the formula for a line. So this is good. Okay. Remember, a single x or a single y. So I have a y here, that's good, but I have an x squared. Yuck, bad, not linear. Okay. Here I have a single x and a single y. That's also good. Okay, single x, single y, that's what I want. Okay, so that is a yes. Here you have a single x and a single y. And I'm not really taking an operation to each of them. I'm just putting a 3/5 with it, and that's okay. That follows this form. Okay, your b is actually your 0, and your m is 3/5, so that is also a yes. Okay, this one is not. Why would you guess? The answer is because you do have a y, you have an x, but you do not like this squared. Okay, no powers. Okay, no powers can be anywhere in your problem. All right, now I say this last one right here. Y is equal to 3.8, and you'll notice there's no x with it. Okay, and that's okay. What that means is you're going to go up 3.8 and draw a horizontal line there. Okay, and that is considered a function. Okay, we're allowed to have lines look like this that are horizontal, just not vertical. Okay, so again, things that are bad, that make things a not a function. We want no powers for x and no denominators for x. Okay, you also want no powers for y. Okay. All right. There we go. All right, so here's what we're going to do. We're going to graph some lines. It says the linear function m is equal to 50 minus 9d. And you're like, where's our x's and y's? They're there. They're just m's and d's instead. Okay. So it says the linear function and the amount amount m of money you can have after buying d CDs. Okay, so I'm going to change these out here. Your x is not an x. It should be a d, and that should be an m. Okay, and what you got to do is you got to figure out how much money you're going to have left after you spend basically $9 for a DVD. Okay, so here's what I like to do. You got to plug your own numbers in. Well, first of all, it says find the domain of the function. Is it discrete or continuous? We'll talk about that in a second. Your disks, okay? What's the lowest amount of disks that you can have? Some people say 1. That's true. Can you have none? You can have none. Can you have -1? Can you have -1 DVDs? No. Okay. And what's the next lowest you could have? Well, a 1, and then a 2, and then a 3, and then a 4. Okay. And then what you're going to do is you're going to take each of these numbers for D and plug them in. Okay. Do you have to show your work? You do. But can you use a calculator to help yourself out? Absolutely. So 50 minus 9 times 0, which is 50. Okay. And then you're going to do it with 1. 50 minus 9 times 1. Well, 9 times 1 is 9. If you subtract that from 50, you get 41. Okay. If you keep going, that's 50 minus, and then you got to now do 2. Okay, which is 32. You do 3, you get 23. And 4 would give you, I think, if you do this in a calculator, this is 50 minus 36 is 14. Okay. Let me pause there for a second, make sure that made sense. All right, now what I'm going to do is I'm going to graph it. And I can count by here by ones. Okay, I'm not going to go past maybe 5 or 6. Who knows? Okay, and then when I want to count upwards, I have to count as much as 50. Okay, so what do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe I'll count by 5s. Okay, and again, D is over here. These are DVDs. Okay, and these here are money. Okay, so I'm going to graph these. Okay, and I'm going to start with the first coordinate. This is 0, 50. So kind of like this. It's kind of like, I'm going to put this over to the left, or to the right, sorry, 0, 50. So I'm going to go over right and left is 0, and then up 50. Okay, and actually it looks like it's supposed to be on this line here. Darn it. I wrote in pen, sorry. Make your dot big. There we go. Did I skip 2? I'm a crazy person. Okay, so there's 2, there's 1, there's 0, 0, 50 right there. Okay. All right, next number is 1 and 41. So here's 1. I'm going to go up to 41. It's about right here. Okay, put a dot. Have to approximate. 2 and 32. So here's 2. I'm going to go up to 32. 3 and 23. 4 and 14. Okay. Now you can keep going. If you were to do it 5, okay, think about your pattern here. What's going on? You are subtracting. It looks like you're subtracting 9 every time. Oh boy, that seems to make sense if you think about that. And so if I keep going and subtract another 9, I'm going to get $5 left. Okay, and it'll kind of cruise down like this. I could do 6, right? But that's going to give me negative $4, and you can't really have negative money. Okay, so that won't really make sense, but it helps me answer this question. Okay, find the domain. What is your x values? Well, I know I can't get any lower than 0. Okay, the most you can have is 0 DVDs. And what's the highest that your DVDs you could have, or you could buy? Well, you can't buy any more than 5, because if you bought 6, you'd be out of money. Okay, so there you go. Now they're going to ask, is it discrete or continuous? Okay, sorry. Is it discrete or is it continuous? This is what we call discrete. Okay, discrete means that we're just drawing these points in. And I drew a line, but does it make sense to draw a line? No. Okay, really you should have no line. Okay, and why should you not have a line? Well, is it possible to have a purchase of 4.5 DVDs or a purchase of 1.5 DVDs? No, you can't purchase parts of a DVD. Okay, so this is discrete. Okay, you can say discrete numbers. And the idea is, why I drew a line there, just to kind of show a representation, you shouldn't have one, because that line means that all the numbers in between these should also be valid. And again, you can't have DVDs in parts. Okay, you can have like 2/3 of a DVD. Okay, all right, these two here, okay, I will have done in class with you. So you should have that type of information. This is the other one that I didn't do. So you have that now, and now you have a full set of notes. All right, if you have questions, you holler at me, you let me know, and I hope you have a great day.